Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 14. This is Section 15.2. It's problem number 14. We want to take the integral of x times the square root of x plus 1 dx. So the first thing we have to do is choose a value for u. You can't really solve this without the substitution method. And there's only one thing that fits, which is stuff under the root. U has to be x plus 1. Again, if you check our normal list of options for u, stuff in parentheses, there's no parentheses. Stuff under the root, we've got u is x plus 1. Stuff in the denominator, we don't have a denominator. Power of e, this problem has no e in it. It has to be what's under the root. U has to be x plus 1. So, du, the derivative of u, the 1x to the first has a derivative of 1, and the plus 1 on the end, this derivative is 0, so 1 plus 0 is 1, and then you have dx for derivative with respect to x. So I have du equals 1 times dx. Let's just write dx. So far it's been pretty straightforward. But I've got a little bit of a problem. That x is not matching up. So I have the integral of, I don't know how I'm going to get that x. Then square root of x plus 1 is square root of u. That's easy. Dx is du. That's easy. How am I going to get that x? Usually, if it's not a perfect match with the du, you just multiply both sides of the equation that has a du in it times some fraction, and it works out. But I can't just make an x show up. So this one is a little different. I'm kind of stuck here. But what you realize after a while, oh, I have an x in this equation. This is an equation. It's got an x in it. I can easily get that x by itself. Let me just pull the 1 over on the other side with the u. So u minus 1 is equal to x. Aha, there's an x. So the integral I have to solve is first x, which can be written as u minus 1, times the square root of u du. That doesn't look much better, but I can actually solve this one. So before I actually start doing the integral, let me get rid of square root of u. Let me rewrite that. So I'm going to leave the u minus 1 in the beginning and make the square root of u into a u to the 1/2 power. Still doesn't look too much better, but now we're making progress. Remember, before I can do the integral, if I'm not going to use the substitution method, I have to clear any parentheses, do any multiplications. Where the parentheses don't have an exponent on it, I can just distribute the u to the 1/2 power through the parentheses. So I'll have the integral of u to the 1/2 times u. Well, that times u, the exponent isn't written. Assume it's a u to the first power. So when I'm multiplying two things with the same base, I add the exponent. So 1 plus 1/2 is 1 1/2, or 3/2. And then u to the 1/2 times minus 1 is minus u to the 1/2. And the du that's out at the end, I'll keep that. Now I can take the integral. I have two variables, both with just a plain old exponent, so they're both going to go 1 over n plus 1 u to the n plus 1, and I'll do that in both spots. So I'm going to have 1 over 3/2 plus 1. U to the n plus 1 is 3/2 plus 1. So that takes care of the u to the 3/2. Now minus, pay attention to the sign, 1 over n plus 1 will be 1/2 plus 1. U to the n plus 1 is 1/2 plus 1, plus some constant. So what I have on the board now is the answer, but it really needs to be cleaned up and simplified. I have all kinds of awful, messy fractions here. So it's going to be 1 over 3/2 plus 1. Think of the 1 as a 2/2. That's the 1. 2 over 2 is 1, but now I have a common denominator of 2. And the numerator is 3 plus 2 more is 5. So I have 1 over 5 halves, u to the same process here. If I got 5 halves when I did it in the denominator, it's going to be 5 halves again when I do it as an exponent. Then minus 1 over 1 half plus 1. So again, the 1, think of it as 2 over 2. So now I have a common denominator of 2. Add the numerators, 1 plus 2 more is 3. So 1 over 3 halves. U to the same fractions being added, same answer. U to the 3 halves plus a constant. Not done yet, but getting better. So in 2 places, I have a fraction in the denominator of a bigger fraction. So to clean that up, what I'm going to do is invert the fraction that's in the denominator, multiply times the top. So the 5 halves, that when it's in the denominator, flips to 2/5 times the 1 that's on the top. 2/5 times 1 will stay 2/5. So I have 2/5 u to the 5 halves minus, so for the next piece I have 1 over 3 halves. So I'm going to invert the 3 halves, it'll become 2/3. 2/3 times the top becomes 2/3 times 1. So 2/3 times 1 is just 2/3. U to the 3 halves plus a constant. Now it's really cleaned up. Keep in mind, it's not done yet. Why? Because I have it written in terms of my new variable. So this is the answer, but I want the answer written in terms of the original variable, in terms of x. But I have exactly what u is equal to. It's equal to x plus 1. So the first part, 2/5 in front stays in front. U to the 5 halves becomes x plus 1 to the 5 halves. Then minus 2/3. U to the 3 halves becomes x plus 1 to the 3 halves. And don't forget you have plus a constant. So that's the answer to the original integral written in terms of the original variable.